Hello everyone, let's look at Leetcode question 160, intersection of two linked lists. In this question, we're given two linked lists as the input value, and they may or may not intersect at some node. Our task is to find that node at which they do intersect, or return null if they do not intersect at all. Okay, so let's look at the details. Here is the custom judge, which will basically tell us the way it's processing our answer and checking if it's accepted. Don't really need to worry about too many of these details. Let's really quickly look at the constraints before the examples. So the number of nodes of list A is defined as m, and for B it's n. These node numbers will be somewhere between 1 and 30,000, and the values themselves of the nodes will be somewhere between 1 and 500,000. Skip A will be defined as the number of nodes it will take to arrive at the intersection point for m, and skip B for the intersection point found at n. The intersection value is 0 if list A and B do not intersect, and the intersect value will be list A at location skip A will be equal to list B at location skip B if list A and list B do in fact intersect. Ooh, that's a lot of details for a simple problem. Now let's look at the examples. Alright, so in this example we have defined A as head A and B as head B, the starts of both linked list values. And then we iterate through a condition while A is not equal to B, we point the nodes to their next values. Otherwise, if there's no more linked list node values, we point to the other linked list. So, going through this example, we start at 4 for A and 5 for B. 4 goes to 1, 5 goes to 6. 1 to 8, 6 to 1, 8 to 4, 1 to 8. And then for A, there's no more nodes, so we point 5 to B, 4 to 5 for B still, and then there's no more nodes for B, 5 to 4, 5 to 6, 4 to 1, 6 to 1. Alright, and this being kind of confusing here because we have the same values, however, this is not the value that we return. And it's important to note that the problem itself defines the intersection values, even though they may or may not be the same. Okay, so 1 goes to 8, and then 1 goes to 8. This is in fact the intersection value because it is defined as this in the program. So we return 8. Here's another example, same concept. We start at 1 for A and 3 for B. End of B for 4, so 4 goes to 1. 1 proceeds to 2. 2 to 4, 1 to 9. There is no more nodes for linked list A, so linked list A points to the start of linked list B. That's 3 to 1. 2, and finally 2. They've intersected at linked list node 2. I apologize for it's kind of messy, but as you can see, the path begins and starts and begins and starts. Eventually they intersect at node 2. Alright, so as you can see, this solution works. Very concise solution. The time complexity of this solution is OM plus N, where M and N are the lengths of the two linked lists. This is because we iterate through both linked lists once to find the intersection point. And the space complexity is O1 because we are not using any additional data structures that grow the input size. We only use 2 pointers to traverse the linked lists. That's it for this video. Thank you for watching.